In the mid-1990s, horsepower loyalty was almost a religion. If you wanted respect in a Texas high school parking lot, you bought a gasoline V8, loud, thirsty, and proudly inefficient. Diesel trucks were mocked as slow, dirty farm tools, written off before they even turned the key. But buried under that ridicule was a mechanical loophole no one at the dealerships wanted discussed. With no race pedigree, no aftermarket sponsorship, and barely $75 in parts, a teenager could quietly flip the script. What followed wasn't just faster trucks. It was a humiliation that exposed how fragile the V8 myth really was. Sleeping giants of the 90s. Picture a typical high school parking lot in Texas, around 1996. The cool kids are revving their engines, boasting about their Ford Mustangs or Chevy Silverados. These trucks were powered by the legendary gasoline V8S of the era, like the Ford 351 Windsor or the Chevrolet 350 Small Block. In the minds of everyone there, these V80S were the pinnacle of speed and power. Tucked away in the back row, however, was usually a clattering, smelly, loud diesel pickup that sounded more like a tractor than a race car. Most people dismissed it as slow farm equipment, assuming it could barely get out of its own way. For a long time, that assumption was actually correct. Before 1994, American diesel trucks were incredibly durable, but painfully sluggish. Engines like the Ford 7.3L IDI or the first-generation Cummins with the rotary VE pump were often naturally aspirated or ran very low boost. They were built to tow hay bales at 50 miles per hour, not to win drag races. They lacked the airflow and fuel delivery to compete with even a mediocre gasoline engine. But the automotive landscape shifted violently in 1994. This specific year marked the arrival of two mechanical marvels that unknowingly launched a horsepower revolution. Dodge introduced the second-generation Cummins 5.9L, equipped with the Bosch P7100 mechanical inline injection pump. Simultaneously, Ford released the 7.3L Power Stroke featuring the HEUI system, which used high-pressure oil to fire the injectors with computer-controlled precision. These weren't just new engines, they were cases of industrial over-engineering. Manufacturers built these platforms with heavy cast iron blocks and forged steel connecting rods designed to last 500,000 miles. While the gasoline V80S were operating near their physical limits just to produce 200 horsepower, these new turbo diesels were sleeping giants. They were operating at a fraction of their potential capacity. The hardware was capable of handling massive pressure, but the factory settings were tuned down for warranty safety. This massive gap between what the engine was doing and what it could actually handle created the perfect environment for a high school student with $75 and a wrench to humiliate a sports car. Cheating the pneumatic safety valve. To understand how these engines were unleashed, you first have to understand how the factory leashed them. The primary restriction was a pneumatic safety valve known as the wastegate. On the standard Holset or Garrett turbochargers of the 90s, this mechanical actuator had a crack pressure set between 18 and 21 psi. As soon as the boost pressure hit that limit, a spring-loaded diaphragm would push a valve open, bypassing exhaust gas around the turbine and forcing the turbo to slow down. It was a safety mechanism designed to protect the engine from overstressing itself. But the genius of the DIY crowd was realizing that this safety mechanism relied on a simple air signal, and that signal could be intercepted. For about $15 in parts from a plumbing aisle, high schoolers were building what is called a manual boost controller. The architecture is incredibly simple. It uses a 1/4-inch brass NPTT as the body, housing a stainless steel ball bearing and a stiff compression spring. By threading a 5/16-inch bolt into the cap, you could adjust the tension on that spring. This is an application of basic physics. By tightening the bolt, you increase the preload on the spring. The ball bearing now blocks the air signal to the wastegate completely until the manifold pressure is strong enough to overcome that spring tension. Instead of opening at a conservative 18 psi, the wastegate remains clamped shut until 30 or even 35 psi. A similar method, known as the boost elbow, achieved this by simply bleeding off air through a small orifice so the actuator never felt the full pressure. Think about that for a second. You are not changing hard parts or rewriting code. You are using a few dollars of brass and a steel ball to trick the mechanical logic of the truck, effectively lying to the turbocharger to force it into working harder. Tricking the electronic brain. As the 90s progressed, the diesel engine evolved from a purely mechanical beast into a rudimentary cyborg. Platforms like the 24-valve Cummins and the later 7.3 Power Stroke introduced an electronic antagonist to the high schoolers' quest for power, the engine control module. While you could mechanically force the wastegate shut with a spring, these newer trucks had electronic eyes. They utilized a manifold absolute pressure, or MAP, sensor to constantly monitor the boost levels. This piezo-resistive device translates pressure into a 0 to 5 volt signal sent directly to the computer. The conflict arises when your mechanical modifications succeed. As you push boost past the factory safety limit of roughly 22 to 24 psi, the MAP sensor output spikes. The computer interprets this high voltage as a critical danger. Its programming immediately triggers a defuel algorithm, or limp mode, drastically cutting fuel to the injectors to save the engine. The truck falls on its face exactly when you want it to perform. The solution to this digital roadblock was found in the aisles of Radio Shack. The Boost Fooler is essentially a hardware hack using a Zener diode, often the one N746A, or sometimes a 10,000 ohm potentiometer. By installing this diode in a reverse bias configuration between the signal wire and the ground, you create a voltage clamp. The diode remains completely passive, allowing the normal signal to pass through until the voltage reaches a specific breakdown threshold. Once the signal threatens to trigger the alarm, the diode activates, bleeding the excess voltage harmlessly to the ground. The engine might be screaming with 35 psi of boost, but the computer receives a steady, safe signal that never exceeds its programming limits. It is effectively a fake ID for the turbocharger, convincing the electronic brain that everything is normal while the mechanical components run riot. The unfair thermodynamic advantage. The reason a $75 plumbing hack allows a farm truck to humiliate a gasoline pickup lies in the fundamental thermodynamic differences between the two platforms. A gasoline engine is thermodynamically fragile. It requires a precise stoichiometric ratio of roughly 14 parts air to 1 part fuel. If you force too much air into a gas engine without perfectly matching the fuel, it runs lean, overheats, and often destroys itself. A diesel engine, however, operates in a completely different reality. It runs in a constant lean state and lacks a throttle plate entirely. This means the engine is capable of consuming as much air as the turbocharger can physically provide. When you manipulate the wastegate to increase boost pressure from the factory 18 psi to 32 psi, you are effectively doubling the mass flow rate of oxygen entering the cylinders. You are force-feeding the engine twice the atmosphere it was designed to handle. And unlike a gas engine, the diesel simply turns that extra air into efficiency. The empirical results of this airflow increase are massive. A stock 7.3-liter Power Stroke from this era might deliver a lethargic 200 horsepower to the rear wheels. By performing these cheap boost modifications and adding a basic fuel chip to utilize the new oxygen, that same engine can jump to 330 horsepower and over 660 pound-feet of torque. To put those numbers in perspective, the 5.7-liter Chevy 350 V8, the standard bearer for performance trucks in the 90s, was rated at only 255 horsepower, with less than $100 in parts. The diesel owner wasn't just catching up to the V8S, they were producing nearly double the torque, fundamentally outsmarting the gasoline technology of the decade. Garage hacks that actually work. Doubling the air pressure inside an engine creates immediate physical consequences. When you jump from the factory 18 psi to 32 psi, you are drastically increasing the separation force acting on the intercooler boots, the rubber couplers that connect the turbocharger to the intake. At stock levels, a 3-inch boot is holding back about 127 pounds of force. At 32 psi, that force spikes to over 226 pounds. The factory clamps simply cannot hold that load, and it was common for these boots to blow off with the sound of a gunshot, instantly killing the engine's power. The solution passed down through the diesel community involved raiding the bathroom cabinet. This is known as the hairspray trick. Mechanics discovered that cheap high-hold hairspray, like Aquanet, has unique chemical properties perfect for this application. After cleaning the oil-soaked rubber and aluminum pipes with brake cleaner, you coat the mating surfaces in a thick layer of hairspray. Wet, it acts as a lubricant, helping the boot slide back on easily. But once it dries, it cures into a tacky, cement-like adhesive that bonds the rubber to the metal. It provided just enough friction to hold 30 psi when standard worm gear clamps failed. The shade tree engineering didn't stop at airflow. To keep up with the fuel demand, enthusiasts would modify the fuel pressure relief valve. By taking the internal spring and physically stretching it out by hand, they increased its free length. This crude modification increased the preload on the valve, forcing the lift pump to work harder and maintain higher pressure at high RPMs. Others would intentionally over-tighten banjo fittings to crush the copper washers beyond their yield point, restricting the fuel return flow to artificially spike rail pressure. It was risky, unrefined, and brilliant, proving that sometimes the best engineering solutions cost nothing but a little ingenuity. Facing the thermal death sentence. There is a reason why every modified diesel truck needs a pyrometer installed on the dashboard. This gauge monitors exhaust gas temperature, or EGT, and it effectively serves as a countdown clock to catastrophic engine failure. While the iron block can handle the pressure, the moving parts inside are governed by strict thermal limits. The aluminum pistons used in these engines have a melting point of approximately 1,220 degrees Fahrenheit. In a stock configuration, temperatures rarely exceed 1,100 degrees. But when you bypass the wastegate and dump extra fuel into the cylinders, EGTs can instantly spike to 1,400 degrees or higher during a hard pull. Sustained operation at this level is a thermal death sentence. The oil jets spraying the bottom of the pistons can only remove so much heat before the aluminum begins to soften, deform, and eventually melt, leading to a complete loss of compression. The danger isn't limited to the engine block. It also threatens the turbocharger itself through a phenomenon called drive pressure. To force a small stock turbocharger to produce 40 psi of boost, you often need an immense amount of exhaust back pressure, sometimes as high as 80 psi. This creates a dangerous 2-to-1 drive pressure ratio. This extreme pressure differential exerts a massive axial load on the turbo's internal thrust bearing. It physically pushes the shaft so hard that the protective film of oil is squeezed out, causing metal-to-metal contact. This is why experienced builders generally consider 32 psi the safe, sweet spot for these stock turbos. Pushing beyond that offers diminishing returns and exponentially increases the risk of grinding your turbocharger into metal shavings or melting your pistons into the oil pan. The battle for clamping force. You have tricked the turbo, fooled the computer, and glued the boots on with hairspray. Now you face a structural problem. The engine block and the cylinder head are two separate pieces of iron held together by steel bolts. In a stock engine, these bolts provide plenty of clamping force to contain the explosion. But when you double the boost, you are drastically increasing the cylinder pressure. You are essentially turning the combustion chamber into a bomb that is trying to blow the top of the engine off. Factory head bolts have a fatal flaw in high-performance applications. They are designed to stretch. Under the immense stress of 32 psi of boost, the bolts act like stiff springs. They elongate just enough to allow the cylinder head to physically lift off the engine block. It might only be a fraction of a millimeter, but that gap is catastrophic. The high-pressure combustion gas needs a place to go, and the path of least resistance is right into your cooling system. This is how you blow a head gasket, pressurizing your radiator until it bursts or pushes all the coolant out into the overflow bottle. This structural failure is why the first real investment after the $75 budget phase is almost always a set of high-strength head studs, typically from ARP. The difference between a bolt and a stud is mechanical physics. A bolt must be twisted into the block, meaning it suffers from both twisting force, or torsion, and downward clamping force. A stud, however, is threaded into the block first. You then tighten a nut down onto it. This eliminates the torsional stress and provides a pure vertical clamping load. It locks the cylinder head to the block with enough force to contain the pressure, ensuring that the only thing leaving the engine is exhaust, not your coolant. The holy grail of injection pumps. If there is a religious artifact in the world of diesel performance, it is the Bosch P7100 injection pump found on the 1994 to 1998 Dodge Cummins. While the Ford Power Strokes required electronic trickery and resistors to make power, the 12-valve Cummins was a purely mechanical masterpiece. It didn't need computer code. It just needed a screwdriver and a bad attitude. The heart of this modification is the aneroid fuel control, or AFC, housing, a mechanical governor that decides how much fuel the engine gets based on boost pressure. Unlocking massive power from this engine involves a trinity of free adjustments that enthusiasts memorize like scripture. First is the star wheel. By spinning this toothed wheel inside the housing, you reduce the spring tension on the diaphragm, allowing the fuel rack to open up earlier in the RPM range for instant throttle response. Second is the fuel plate. This steel plate acts as a physical backstop for the fuel rack. By sliding the stock plate forward or taking it to a grinder to carve out a custom number 0 or number 10 profile, you physically allow the pump to inject significantly more diesel. Finally, there is the rack plug, which can be swapped or modified to allow even more internal travel. When you combine these mechanical tweaks with a $25 boost elbow to supply the necessary air, the results are staggering. You can take a factory 160 horsepower farm truck and tune it to over 300 horsepower in your driveway without buying a single aftermarket performance part. It is the purest form of hot rodding, using mechanical leverage to find power that was hiding in plain sight. From garage hacks to empires. The interesting thing about this era is that it did not just annoy the neighbors, it created an economy. The massive diesel performance industry we see today, with titans like BD Diesel, Quadzilla, and Banks Power, did not start in a vacuum. They largely began by observing what high school kids were doing in their driveways and refining it into something you could sell in a plastic box. Take the boost fooler. A teenager with a soldering iron could build one for 90 cents using parts from Radio Shack. But most people are afraid of cutting into their factory wiring harness, so the aftermarket stepped in. They took that same Zener diode logic, wrapped it in a weatherproof casing with factory-style connectors, and sold it for over $100. It was the exact same electrical trick, just produced for the masses who wanted the power without the risk of a homemade circuit board shorting out in the rain. The same happened with the mechanical hacks. The hairspray trick was messy and unreliable in the long term. Companies like Mishimoto and Diesel Sight saw the failure point and engineered heavy-duty silicone boots with hard PVC liners that would not slip, rendering the can of Aquanet obsolete for anyone with a credit card. What started as a subculture of shade tree mechanics outsmarting their engines with hardware store parts eventually matured into a multi-billion-dollar marketplace. The $75 boost trick did not just make trucks faster. It proved that there was an insatiable market for unlocking the potential that the factory had hidden away. The $75 loophole. The technical feasibility of the $75 boost trick wasn't just a tall tale told in high school parking lots. It was a confirmed exploitation of mechanical headroom. By combining a $15 pneumatic valve from a plumbing aisle with a 90-cent electronic resistor, teenagers effectively doubled the volumetric efficiency of their engines. They bypassed the factory's safety logic and forced these industrial platforms to perform at their physical limits. The results were undeniable. A heavy farm truck could suddenly out-accelerate a gasoline V8, producing torque numbers that shouldn't have been possible for the price. But this performance came with a heavy tax. The Texas high schooler wasn't just outsmarting the dealership, they were gambling with thermodynamics. Every hard pull was a dance between victory and a melted piston or a blown head gasket. This era represented a unique, fleeting moment in automotive history. It was a time when engines were built with enough mechanical slop to be exploited by a kid with a wrench, long before encrypted computers and emissions equipment locked everything down. It was the ultimate intersection of poverty and engineering ingenuity. And that is how a $75 receipt from a hardware store turned a slow diesel pickup into a legend that is still talked about today.